Hey, believe it or not, this is our last lesson for pre-cal. It's equation conversion, and the reason we're looking at this is to see how to take something from polar form and convert to rectangular form. So if I'm giving an equation in terms of polar coordinates, or that radius and theta, I want to get it back to rectangular form. So we're just going to look at some examples of how to do this. It's a little bit tricky because there's more than one way to do that. If I'm starting with r equals 2, that would be all that I would be given, and I want to get that back into rectangular form. I'm going to pick one of my equations from yesterday. So yesterday when we talked about some equations, let me just jot those down to jog your memory. R squared equals x squared plus y squared. We know that from the circle. We know that the tangent of theta is y over x. We know that x equals r cosine of theta, and we know that y equals r sine of theta. So those are our four main formulas. When we're given something like this and we want to go over to rectangular coordinates, we need to start by just figuring out which equation do we know the most information about. Now, notice the bottom three has something to do with theta. We don't know anything about theta, so that's really not going to help us in this case, which means we want to use that first equation. If we use that first equation, we can plug in that r. So I have 2 squared equals x squared plus y squared. I've already eliminated my r and my theta, which is good because I need to get rid of those to get back into rectangular. Rectangular, of course, only involves x and y. So now I can start simplifying. 2 squared is 4 equals x squared plus y squared. And to get this in the most basic form, we want all of the information on one side, so we want to set it equal to 0. To do that, I'm going to subtract the 4 from both sides, and then I'm just going to go ahead and flip it around. So I have x squared plus y squared minus 4 equals 0. And now this is a rectangular equation. The r and the theta have been completely eliminated. If you are more familiar with getting something to say y equals, you could do that as well. I don't necessarily have to do that, but I could. And you would know how to do that by subtracting the x squared, moving the 4, and taking the square root of y. You know how to do that, so I'm not going to go over that with you. Example number 2 is, what if I was given something just a theta? So if I was given theta equals pi over 3. Okay. In this situation, the equation we just used wouldn't make any sense because we don't know anything about r, x, or y. Instead, we're going to want to pick one of the equations that has something to do with theta, x, and y. Of course, that would be the tangent function. I don't want to use these two because I don't know anything about r. So if I'm starting with this and I want an equation in rectangular coordinates, I'm going to start with the tangent, and instead of theta, I'm going to replace that with pi over 3 is equal to y divide x. I know the tangent at pi over 3. If I think about my unit circle, that would be up here. My coordinates, of course, would be, let's see, square root of 3, 1/2 and square root of 3 over 2. How to think about that for a second. If I think about my tangent, that would be the square root of 3 over 1, or just the square root of 3, equals y over x. I want to go ahead and get y by itself. We just talked about how that might be a way you wanted to go in this direction to get it into rectangular coordinates. That's how you're familiar. So I'm going to cross multiply. 1 times y is y. Square root of 3 times x is square root of 3 of x. And so that's all. I'm totally done now. And that's my new equation in rectangular form. If I wanted to go like I was going in example 1, where I get all of my stuff on the same side, I would just subtract this over here and set it equal to 0. Easy enough. Let's do one more example. And let's do if r equals the secant of theta, if that's what I was given right off the bat. Okay, in this case, I don't see any of my equations yet, right? I don't see anything that's easy to do. Now, I do have an r and theta, so my first instinct is that it's going to be one of these. Let's go back to what we used to do when we would talk about our trig functions. If we saw something like secant, cosecant, cotangent, that kind of stuff, we would always want to put it back in terms of sine and cosine. So let's do that. I'm going to say r is equal to 1 over, and you remember that that's 1 over the cosine of theta. To make the fractions easier, I'm going to go ahead and multiply both sides by cosine of theta to get rid of that denominator. When I do that, these two cancel, and I have r cosine of theta is equal to 1. And now you should be saying, oh, Miss Lawler, look, r cosine theta, so that can be set equal to x. And so x is equal to 1. I got rid of my r, I got rid of my theta. My coordinates have been converted, my equation has been converted, and my new answer is x equals 1. And that's all there is to it. You're just going to have to look at the 4 equations that you know and try to relate the information that you're given to get rid of the theta and the r. That's your goal today. Here's your assignment. It's A14, last assignment of the year. and that is page 784. It's numbers 50 to 56 even. That's just a few for you to look at. And I think you'll do great on that. If you have questions, please let me know.